Hi, I'm Mr. Chen. You're welcome to my study room. Today, our study is on identity and inverse elements, what they are, and some examples of questions that require us to find identity or inverse elements. Let's go on straight to the lesson. In mathematics, an identity or neutral element is any element that's combined with other elements under an operation and leaves the other element unchanged. I'll give an example to explain that, or I'll give examples to explain that. Let's first take the operation addition. For addition, we take a number like 0. 1 plus 0 will be the same as 0 plus 1. And both of them will give us the answer 1. Also, 5 plus 0 will be the same as 0 plus 5, and that will give us 5. And then let's use another number. 13 plus 0 will be the same as 0 plus 13, and that will give us 13. So in each of these instances, we added 0 to the numbers involved and we got the same numbers back. Based on that, we can confidently conclude that therefore 0 is an identity element under addition, or simply put, 0 is additive identity element. Then we can also take multiplication. For multiplication, we'll take 1. So 3 times 1 is the same as 1 times 3, and both of us will give us 3. Also, 7 times 1 is the same as 1 times 7. Or both of them will give us 7. And also maybe 25 times 1 is the same as 1 times 25. And both of them will give us 25. So since we combine, in each case we combine 1 with each of these numbers using multiplication sign, and we got all the numbers back, we will conclude that therefore 1 is an identity element under multiplication, or 1 is a multiplicative one is a multiplicative identity element. Then let's try maybe subtraction for the last before we move on. We go to subtraction, we take 3 minus 0, and this is not equal to 0 minus 3, because 3 minus 0 will give us 3, and 0 minus 3 will give us negative 3, so they are not equal. Subtraction is not commutative. Therefore, 0 is not identity element, and good. 0 is not an identity element under subtraction. These are just illustrations to explain the phenomena of identity elements for your proper understanding. Then we can go into identity elements under binary operations. So just as we did for multiplication and addition, under binary operation, we are saying that for any element E, which is shall be calling the identity element, when we combine it with another element, let's say A, we should get our A back. That means that for any operation star, A star E, it should be the same as E star A. And after that, we should get our A back. So that is a basic assumption we are going to use for binary operation to get our identity element. That identity element, that assumption is that, or that hypothesis is that A, for any operation, not only star, it can be delta or any other operation. For any operation, when we combine an element with the identity element, or we change the positions, that means it should be commutative. We should get our original number that we combine with the identity element back. So that is the basis on which we are going to be working. That is the basis on which we are going to be working. The basis is that whenever we combine a number with the identity element, we should get the number back. Let's take an example. All right. A binary operation is defined on the set R of real numbers by A star B equals A plus B plus 5AB. Find the identity element. To solve this question, we are going to start our solution with the initial statement that if E is the identity element, then A star E should be the same as E star A, and that should give us A. And what this means is that in this R definition for our binary operation, wherever we see B, we are going to put E there, and then after that, the E, which is the identity element, after that we make the identity element the subject to see what we get. So let's go on straight to do that. So that means that A plus E plus 5AE should give us A, because that is the fact we have established for identity element. Then when we combine any element with the identity element, we should get that element back. So it means that when we combine here using the operation star, we should get our A back. That's why we equated it to A. And that's what we did for the addition and the multiplication before we concluded that 0 is an additive identity element and 1 is a multiplicative identity element. So let's go ahead and make E the subject, which is what we are looking for. So A plus 5AE will give us A minus A. Then we factor E out to get 1 plus 5A. That should give us 0. Then our E, we divide both sides by 1 plus 5A. Our E is going to be 0 over 1 plus 5A. So any number dividing 0 is 0. So therefore, our identity element is 0. So that's how we find an identity element. Let's take another example. A binary operation star is defined on a set R of real numbers by m star n equals n plus n plus 3/4. Find the identity element. Our initial statement will still count that if E is good. So if E is identity element, then M operation, in this case is star. So M star E should be the same now as E star M. And that should give us our M back, because the identity element doesn't change the number we are operating it with. Good. So we go ahead and fix the M and the E into our original definition. That means that our M operation E will now be M plus E plus 3/4. And again, we are just replacing the second element with the identity element. That's what we'll do in any other solution. When you're finding identity element, you first replace the second element in the definition by E, which we are calling the identity element. Then you make the E the subject, and that should give us our M back. So this will imply that our E will be equal to M minus M minus 3/4. Then that means our E will be equal to M minus M is 0. So negative 3/4. And that becomes our identity element. Then let's move on to the inverse element. Inverse element is any element that when we combine with another element, we get an identity element for that operation. Let me state that again. For you to find an inverse, or for you to identify that a number or an element is an inverse of another, It means that when you combine that number with the original number under any operation, you should get the identity element for that operation. So for example, at the beginning of this lesson, we identified that additive identity element is 0. So that means that any number we combine with another number using addition and we get 0 is the inverse. So for example, 5 plus -5 will be the same as -5 plus 5, and that will give us 0, which is the identity element we identified for the operation addition. Because of that, we can say that therefore -5 is the inverse of 5 under the operation addition. Very necessary. The same way, when we go to okay, let's take another one. Let's say we take a number like 8 plus -8. We will get, sorry, -8. That should be the same as -8 plus 8, which will give us 0, which is the identity element under addition. Because of that, we will say that -8 is the inverse of 8 under addition. Very necessary. Under addition. It is only under addition that it is the inverse, because it gives us the identity element under addition. Then let's take multiplication. Good. For multiplication, we want a number that when we multiply with another number, you get the identity element for multiplication, which is 1. So maybe let's call that number A. That means that A times, let's say 3, should give us 1. And that is 3A should give us 1. We divide both sides by 3. A will be equal to 1/3 or 1/3. So that means that 3 times 1/3 should give us 1, which is our identity element under multiplication. Remember, here I brought the 1/3 second because multiplication is commutative, and all along we said A times B equal to B times A. So that's why I did that. And that should give us, so what this means is that since we multiply we multiply 1/3 with 3 to get 1, which is the identity element, it means that under multiplication, 1/3 is an identity, is the inverse of 3. We can do the same for another number. Let's say 7 times 1/7. That will be the same as 1/7 times 7, and that will give us 1. So since 1/7 is combined with 7, under multiplication to give us the identity element under multiplication, we will say that 1 over 7 is the inverse of 7. Are we okay? Good. Then we can go to binary operation just like we did for the identity element. When we come to binary operation, we are just saying that for a number to be the inverse of another number, when we combine that number with, or when we combine that inverse with the number, we should get an identity element under any operation at all. So that is a basic assumption, that if the number is the inverse of another number, then when we combine the two of them, we should get the identity element under that operation. What does that mean here? It means that because binary operations are not the basic operations that we know, or the universal operation signs that we know, whenever we are giving the definition for a binary operation, we should first go ahead and find the identity element before we can find the inverse, or unless the question gives us the identity element. If the question doesn't give us the identity element, then for any operation, we have to first find the identity element before we can find the inverse, because our basic assumption is going to be that any number, if let's take the number to be a, if a is any element at all, then a operation, its inverse, which we will call this way, we will write this way, should be the same as a inverse operation a. Are we okay? Then that should give us the identity element, which we have found already. So this is the basic assumption on which we are going to move with the inverse element. That when you operate any number at all with its inverse, we should get the identity element back. So for any binary operation, based on the definition, we have to first go ahead and find the identity element. After finding the identity element, we fix it into this general preamble, then we can go ahead and find the inverse element. So let's take a quick example for me to use to explain this more. All right, a binary operation delta is defined on the set R of real numbers by a delta b equals a plus b minus 5ab, where a and b belong to R, is closed under the operation delta. Find the inverse I, find the inverse element, and then I calculate the inverse of negative 1 over 4. All right. We are going to let remember I said at the beginning of the lesson that we have to find the identity element first before we can find the inverse element. So we are going to find the identity first. Good. So if the identity element is E, then we already know that A delta E should be the same as E delta A, and that should give us A, because the identity element doesn't change the number after operation. So let's fix that into it and see. So that means that A plus E minus 5AE should give us our A back. Then that is true. So let's make E the subject. E minus 5AE should be equal to A minus A. So we factor E out. To have 1 minus 5A being equal to 0. We divide both sides by 1 minus 5A. That means our identity element is 0. Then, now that we have found identity element, we can now go ahead and find the inverse element. And that is also based on the assumption that, okay, let's define our inverse element. So we are letting A, you can use any symbol you want, but because we are using A, I'm just using A inverse as this. So let this be the inverse of A. Or if you are writing it like the way I did first, we will say that if this is the inverse of A, then it's all the same. So based on this, we can say that A delta A inverse should be the same as A inverse delta A, and that should give us our identity element. That is a basic assumption for inverse element. So with that, let us go ahead and see. We are now going to fix the A and the A inverse into this definition, this same definition, the definition for this question. So you are still using it. That means you are going to have A plus A inverse minus 5A times A inverse, and that should give us 0. Remember, there isn't 0 because the identity element we found for this operation is 0. So that should be equal to 0. Let's go ahead and work. Our main aim here is to make A inverse the subject. So that is what we are going to do. Let's first group the A inverse terms. We factor A inverse out to have 1 minus 5A being equal to negative A. We divide both sides by 1 minus 5A. We are going to get A inverse being equal to negative A over 1 minus 5A. So this answer we have here is, therefore the inverse of A is negative A over 1 minus 5A. So this is the inverse we are looking for. Then now we are going to the second part. Whenever they ask you to find the inverse of any number, simply wherever you see the variable, you fix the number there and find negative 1 over 4 over 1 minus 5 times negative 1 over 4. So this will give us 1 over 4 divided by 1 plus 5 over 4. And this will give us 1/4 divided by 9/4, and this is the same as 1/4 times 4/9, and that will give us 1/9. Therefore, the inverse of -1/4 is 1/9. Let's take another example. Good. The operation star is defined over the set R of real numbers by A star B equals A plus B plus 2AB for all AB belongs to R. Well, that means where A and B are real numbers. And state which element has no inverse. Determine the inverses of 2 and 3. Good. So again, the first question here is we should state which element has no inverse. There, it only means that we are first of all going to find the inverse. After finding the inverse, we'll find the number that will make the inverse undefined. Any number that makes the inverse undefined means that that number has no inverse. That's why it makes it undefined. So let's go. Like we said from the beginning, for us to be able to find the inverse, we must first find the identity element. So that's where we are going. So we say that if E is the identity element, then A star E should be the same as E star A, and that should give us our A back because identity element doesn't change the number. So now we are going to fix A and E into this definition that we have here. Thank you. So that gives us A plus E plus 2AE, and that should give us our A back. And those who are still confused by here, we are just replacing the definition, the second element is B. But in our preamble here, the second element is E. So wherever we see B, we are replacing B with E. That's just what we are doing. And now we are looking for E, which is the identity element. So we are going to make that the subject by regrouping all the E terms at one side and any term with other E2 at one side. So that's going to give us E plus 2AE. That should give us A minus A. We factor E out to get 1 plus 2A. That should give us a 0. And then our E will be equal to 0 because when we divide both sides by 1 plus 2A, any number 0 divided by any number at all is 0. So that is our identity element. Then now we are going to find the inverse element. Remember, we cannot get the number that has no inverse if we don't know the inverse element. So let's go and find the inverse element. Good. So if A exponent -1 is the inverse of A, then A star A inverse should give us A inverse star A equal to E. Again, remember because the inverse is the inverse of A, I have decided to use A exponent -1 as the inverse. So that any number I am given, I'm to find the inverse of that number, or any variable, I'll just make that variable, I'll just take that variable exponent -1 as the inverse of the variable. But some books also use other letters. You can choose to use a different letter to replace the inverse. The most important thing is that you will define it. You will define your inverse. So this is more or less like, let this be the inverse of A. If I say if this is the inverse of A, it still means that let this be the inverse of A. So that in my calculation, wherever you see A exponent negative 1, that means that is what I am calling the inverse of A. So let's go ahead and fix it into our definition of our formula. Thank you. So that gives us A plus A inverse plus 2A inverse, and that should give us 0, which is our identity element that we found earlier. So we are now making A inverse the subject. A inverse plus 2A inverse should be equal to 0 minus A. We factor A inverse out, we get 1 plus 2A, and that should give us negative A. Then we divide both sides by 1 plus 2A. That means our A inverse is going to give us negative A over 1 plus 2A. So this is the inverse of our A. This is the inverse of our A. We now come to the question, which element has no inverse? This is which element will have no inverse. Like I explained at the beginning of this question, this number, this A will, A will have no inverse if this A inverse here is undefined. And the A inverse here will be undefined when the denominator is equal to 0. That is just what we are going to do. So we will say that A will have no inverse. So A will have no inverse if the denominator is equal to 0. Because if the denominator is equal to 0, it means that A inverse is now undefined. So for any number of A that will make A inverse undefined, that is the number that has no inverse. A will have no inverse if 1 plus 2A, which is the denominator here, is equal to 0, because that is what will make A inverse undefined. Then we go ahead and make A the subject. So 2A will be equal to 1 minus, 2A will be equal to 0 minus 1, and 2A will be equal to negative 1. So we divide both sides by 2 to get our A being equal to negative 1 over 2. So that means that this inverse, this A inverse will be undefined when A is negative 1 over 2. Therefore, negative 1 over 2 has no inverse. Yeah. Therefore, the element which has no inverse under the operation star is negative 1 over 2. And that is just what they are looking for. So for any question at all, you will just have to find the number that makes your inverse undefined. It means that that number has no inverse. Thank you. Then we go to the other part of the question. The question says you should find the inverses of 2 and 3. And that one, because I want you to use this formula to find the A inverse. This is the formula for the A inverse. So you just fix whatever you see A, you fix 2 to find the inverse of 2. And whatever you see A, you fix 3 to find the inverse of 3. And I would like you to do that one on your own, because I want you to try to see whether what you have learned you got it. So I'll just write the answer so that you check. Let me just call this I. So the inverse of 2 is -2 or 5. And the inverse of 3 is -3/7. I hope you got those answers. You can pause it and work it. Then you compare your answers. And I hope you got those answers. If yes, well done. You have done well. If no, continue to try again. You'll be fine. And then we take the very last part of this. Another question I want you to try and see. This one, they give you only element alphabet in a table, and they ask you to find identity element and the inverse element. So let's try that before we bring today's study to an end. Well, so this is our question. The table shows the operation delta on the set A, B, C, D. Use it to answer the following questions. The first question is state the identity element. So here we don't have numbers. How do we find the identity element? We are just going to use our definition of identity element to guide us. That with the identity element, when we operate a number with the identity element, we should get that number back. So for example, when we take A, when we operate A with the identity element, we should get A back. When we operate B with the identity element, we should get B back. When you operate C with the identity element, we should get C back. When you get D, operate D with the identity element, we should get D back. So let us see from the table where, because this is the answer for A delta A. This is the answer for A delta B. This is the answer for A delta C. And in that order, this is the answer for C delta A is A. C delta C is C. C delta D is D. Yes. So this is how we are going to find. Now, based on that definition of identity that we know already, or neutral element that we know already, we are now going to check from the table. A delta C gives us A here. B delta C also gives us B. C delta C gives us C. And then D delta D gives us D. Yes. So it means that C is our identity element. That is why when we operate any number with C, we get the same number back. So therefore, the identity element is C. Then we go to B. You have to find the inverse element. Still, the definition of inverse. Now that we know our identity element to be C, let us find out which element we are going to operate each of the letters with to get our C back, because that is the definition of inverse element. Inverse element says that when we operate a number with its inverse, we should get the identity element back. And now we know the identity element to be C. So that means that which number should we operate with A to get C? And A delta B gives us C. So it means that the inverse of A is B. A inverse is B because A delta B gives us C, which is the identity element. And He said we have to find the inverse of D2. So D delta D gives us C. That means that the inverse of D is equal to D, because D delta D gives us the identity element. Then we find our C, which is state whether or not the operation is commutative. Commutative property tells us that whether we change the position of two numbers or not, we should get the same answer. So that should show that if the operation delta is commutative, then A delta B should give us the same answer as B delta A. Let's see whether we will get that from the table. So let's take any of them, not only A, we can take any of the element. So let's take A delta C. A delta C gives us A. A delta C gives us A. Now let's take C delta A. C delta A also gives us A. So that means A delta C is equal to C delta A. Let's take another one just to confirm. So let's take D delta B. D delta B gives us A. Okay, I don't want another one that will give us A, because if you keep getting A, someone might be thinking it's always A. So let me use D delta C. So D delta C gives us D. So let's just find C delta D. C delta D also gives us D. So D delta C is also equal to C delta D. So since even if we change the position of the element, we get the same answer, we will conclude that therefore, remember, it is not the answer that is commutative, it is the operation. So therefore the operation delta is commutative, because when we change the position of any two elements, we still get the same answer. Good. So that is why today's study comes to an end. The study on identity and inverse element under binary operations. I hope you enjoy your study with me today. I hope to meet you once again in my study room. And the appeal to you right now is that if you have not subscribed to this channel yet, this is the time to do that. Please subscribe to this channel so that anytime I enter my study room, you also have a notification that there is some study going on in Mr. Chu's study room. I hope to see you again in the next lesson. Thank you and see you next time. Bye bye.